In this video, I'm going to look at solving rational or a rational equation. So what a rational equation means is any equation, so it's an equal sign, making an equation, with at least one rational term. So this is probably the simplest type of rational equation you're going to see because there's only one rational term and it's equal to zero. So in this case, there's a few different ways you could go about solving this or think about solving it. So I have x minus 5 divided by 2x plus 1 equal 0. Um, One way to do this is just think about how you would solve uh, a linear equation. Let's say like x over 2 equals, let's say 5. Well, the way you'd solve that is you want to remove the denominator. So you multiply both sides by 2, and these sides divide out, and you get x equals 10. So you can kind of do the same thing here. We want to remove the denominator. So the way we're going to do that is multiply both sides by the denominator of 2x plus 1. And it's an equation, so whatever you do to one side, you can do to the, if as long as you do it to the other, you haven't changed the value. So what would happen here is the 2x plus 1's would divide out, and then here you have 0 times 2x plus 1, which is of course 0. And now we've turned it into a linear equation. X minus 5 equals 0, so x is equal to 5. And that would be the solution to this equation. So x equals 5. One thing you have to be a little bit careful about is when you do this, when I'm dividing 2x plus 1 divided by 2x plus 1, I need to make sure 2x plus 1 does not equal 0, because you can't divide 0 by 0. So you have to figure out the restriction, and the restriction would be whenever the denominator is equal to 0. So that'd be 2x plus 1 equals negative 1, or x equals negative 1/2. So that's going to be a restriction. So you should always state that x cannot be equal to negative 1/2. State your restriction at the very beginning. So just be a little bit careful with that. But this is an example of how you would solve a rational equation, and this is kind of the simplest one you're going to see. There is a second way to think about this, which doesn't involve multiplying both sides of the equation by 2x plus 1. So same equation, x minus 5 over 2x plus 1 equals 0. Here I can kind of just logically think about this fraction. I have a fraction equal to 0. But when does a fraction equal 0? The only way a fraction is going to be equal to 0 is if the numerator is equal to 0, right? So 0 divided by something would be equal to 0. So I'm just kind of ignoring the denominator. I'm not multiplying both sides. You still, in that case, do have to consider the case, or rule out the case, where the bottom is 0, which was x not equal to negative 1/2. But you get the same answer. I'm just thinking about it in a little bit different way. This idea of not including or stating the restrictions is important, because you could have something like this. Let's say you had something like that, and you blindly just went and ignored the restriction and just said, okay, I'll just take the numerator and set it equal to 0, or multiply both sides by 2x plus 2, and then I would get x equals negative 1. The problem is this is not actually a solution to this equation, and the reason it's not a solution is because x equals negative 1 is a restriction. The bottom, 2x plus 2, if I had set that equal to 0, I would have had 2x equals negative 2, so x is minus 1. So that means x cannot be negative 1, because that would make the bottom equal to 0. So that's a problem. I'm saying x equals 1, negative 1 is a solution, but that was also a restriction. And if it's a restriction, it's not a solution. So this is actually not true. So what's going on here? What is the solution to this equation? Another way to think about this, or something you could do with any equation is I could have simplified this expression first. Let's say I had noticed I can factor that denominator. And if I factor the denominator, I'm going to have 1/2 equals 0, which is never true. And what does that mean? That means this equation here that I came up with has no solutions. So this example here is just to kind of show you that you have to state the restrictions, because if you don't state the restrictions, you might end up saying that a solution is a solution when it's not, because it was a restriction. So that's kind of the reason that you have to always state the restrictions. It's not going to happen very often, but just in case and for the sake of completion, you should always state that.